Let us study some special distributions in this video. First distribution, uniform distribution. Uniform distribution, also known as rectangular distribution, the distribution that has a constant probability. If you look at the PDF, if in A to B, it has the value 1, and PDF is shown here because when you integrate PDF, you will be getting PDF. When you integrate a PDF, which is a rectangular in nature, you should get a ramp. Then for this series, you have a constant value. So it is defined for all values of B, which is greater than A. Let us try to find out the mean, mu x, that we get it as A plus B by 2. The PDF is already defined here. PDF is given as fx of x is equal to 1 by b minus a for the series x between A and B. And by integrating PDF, we will get the PDF. When you integrate this with respect to PDF, we get this as x minus a divided by b minus a for the series. Uniform distribution. Uniform distribution, sometimes also known as rectangular distribution, is a distribution that has constant probability. This is the PDF defined for uniform distribution, and it is defined as fx of x is equal to 1 divided by b minus a, x value varying between a to b. And here you can understand that b should be greater than a. From this PDF, we can calculate CDF. CDF can be calculated as integral of CDF dx. This is equal to integral of minus infinity to infinity 1 by b minus a dx. In this case, you can see that it varies between a to b. So x can take anywhere from a to x. So this is x divided by b minus a. So a to x. So it is x minus a divided by b minus a. So therefore, you can see here between a and b, you have x minus a, b minus a. This is a straight line equation. So you can observe here PDF is a straight line equation. After that, for all values of x greater than b, its value is going to be 1. Now let us try to find out the mean. Mu x is equal to a plus b by 2. So here you can get the mean value as integral of minus infinity to infinity x into CDF dx. So this gives you minus infinity to infinity x divided by b minus a dx. So here it varies from a to b. So here when you integrate, it is x squared b minus a by 2 varies between a and b. And when you simplify this, you get this as b square minus a square by 2 b minus a, which will give you a plus b by 2. This is the mean. Then you can also calculate the variance. Sigma x square is equal to b minus a whole square by 12. This can be computed using the formula variance of x, that is sigma x square, standard deviation x square is given by, it varies between minus infinity to infinity. That is, in this case, it is a to b, and it is x minus mu x. Mu x is given by a plus b by 2 whole square dx. When you simplify this, when you integrate this and when you simplify this, you get the answer as b minus a whole square by 12. Finally, we need to compute the characteristic function phi of j omega. You will get it as e to the power j omega minus e to the power j omega a divided by j omega b minus a. This derivation we will be doing it in the next video. Next is exponential distribution. It is also known as negative exponential distribution. It's a probability distribution that describes the time between events in a Poisson process. Its PDF is shown here and PDF is shown here. And PDF is defined as fx of x is equal to lambda e to the power lambda x for x value greater than or equal to 0, and it is 0 for x value less than 0. And PDF can be computed by integrating the PDF function between the limit 0 to infinity. So PDF function is lambda into e to the power minus lambda x to dx. So when you integrate this, you get this as 1 minus lambda e to the power minus lambda x for all values of x greater than or equal to 0, and it is 0 for x less than 0. Next, we need to compute the mean. Mean value can be computed as the limit 0 to infinity. It is x into the PDF. PDF is lambda e to the power minus lambda x dx. When you do this integration, you will be getting the answer as 1 by lambda. Similarly, you can compute the variance, which is the standard deviation whole square. It is the integration of 0 to infinity x minus mu x. Mu x is here 1 by lambda whole square into PDF. PDF is lambda e to the power minus lambda x dx. Its answer is going to be 1 by lambda square. And finally, we have the characteristic function phi of j omega, which is defined as lambda divided by lambda minus j omega. It is this derivation is shown in the upcoming video. Laplace distribution. The Laplace distribution is also called as double exponential distribution. It's a distribution of differences between two independent variables with identical exponential distribution, and it is defined for all values of b greater than 0. And here the PDF is shown in this figure. PDF is shown here, and the PDF is defined as fx of x is equal to b by 2 exponential minus b modulus of x. This can be defined as, this is b by 2 e to the power bx u of minus x plus b by 2, it is e of minus bx u of x. And now when you want to get the CDF, you have to, common factor is b by 2, take it out, then it is integration of minus infinity to 0 e to the power bx dx plus 0 to infinity e to the power minus bx dx. When you simplify this, you will be getting the answer as 1 minus exponential minus dx for all values of x less than or greater than or equal to 0. It is half exponential of dx for all values of x less than 0. Now we can compute the mean. The mean turns out to be 0. The computation of mean is, once again, it is b by 2 is taken out. It is minus infinity to 0 x into e to the power bx dx plus it is 0 to infinity x into e to the power minus bx dx. When you do this, you will be getting the answer as 0. Similarly, since mu x is 0, you can compute the we can compute the variance that is sigma x square as x square into CDF in dx. So here once again it is d by 2, it is minus infinity to 0 x square e to the power dx plus 0 to infinity, it is x square e to the power minus dx. When you simplify this, you get this as 2 divided by d square. And the characteristic function is given by d square divided by omega square plus d square. Next distribution is Gaussian distribution, popularly known as normal distribution. If the number of events is very large, then the Gaussian distribution function may be used to describe the physical event. The Gaussian distribution shown is normalized so that the sum over all values of x gives a probability of 1. It is always defined for modulus of mu x less than infinity and standard deviation greater than 0. Its PDF is shown here. PDF is shown here. PDF is defined by this function 1 divided by root 2 pi sigma x exponential of x minus mu x whole square divided by 2x sigma x square. And the CDS can be computed by integrating this. We will be getting the effect of x is equal to characteristic function phi of x minus mu x by sigma x, and the mean is always v of x equal to mu x, and the variance is sigma x square, and the characteristic function exponential of j omega mu x minus omega sigma x square by 2. Next distribution is the binomial distribution. It can be thought as the probability of success or failure outcome in an experiment. It is a type of distribution that has two possible outcomes, either a success or a failure. It gives a discrete probability function. You can observe here from this graph. It gives a discrete probability function. It is defined for p, q greater than or equal to 0. And always the p plus q is equal to 1, and n for all values of n greater than or equal to 1. And PDF is defined as the effect of x is summation k value varying from 0 to n, p and k in delta of x minus k. PDF is defined as fx of x, it is summation k value varying from 0 to n, p and k u of x minus k, because we are integrating delta function. When you integrate a delta function, you are going to get a step function. And the mean is always given by mu x is equal to n into p, and the variance is given by sigma x square, that is equal to npq. And the characteristic function is defined as q plus p e to the power j omega whole to the power n. Last distribution is the Poisson distribution. The Poisson distribution is used to model the number of events occurring within a given interval, and it is defined as Pk is equal to d to the power k divided by k factorial e to the power minus d for all values of k varying from 0, 1, 2 to infinity. PDF is defined as summation k value varying from 0 to infinity Pk delta of x minus k, where Pk is defined by this equation. And when you integrate this, you get a step function u of x minus k, which will give us PDF. And the mean value mu x is always equal to b, and the variance is also equal to b. Characteristic function is defined by this formula. Thank you. In the next video, let us solve some problems on mean and variance.